Now let's talk about continuity without a picture. So we want to remember first off from limits or algebra, a blank makes the denominator 0 but factors and cancels with the numerator, versus a blank makes the denominator 0 and does not cancel with the numerator. So which one factors and cancels nicely and which one does not cancel? It is a whole will factor and cancel with the numerator. When we did limits, we said that the limit would be a finite regular number because we got to cancel out what made us divide by 0, versus a vertical asymptote makes you divide by 0 and cannot be factored and canceled. Makes you divide by 0 no matter what. So looking at these examples, we're going to identify x values where the following are discontinuous, state the x value and whether it's a whole or a vertical asymptote that's making it discontinuous, and then also give an interval of continuity to just practice writing things out in interval notation. So in this first example, we have f of x is x to the fifth plus x squared plus 4. And we want to figure out where is it going to be discontinuous? Where do we divide by 0 on this? Well, there's no denominator. This is called a polynomial, right? What do we say about polynomials? Polynomials, so it's always continuous. There is not going to be a place that is going to be a whole or a vertical asymptote on this. There's not even a denominator. So it's always continuous, and we're going to practice writing some interval notation. So we're going to write the interval of continuity, which I'm just going to write as IOC. So this interval of continuity is every single number. So how do we write that in interval notation? That is every number from negative infinity to positive infinity, continuous everywhere. The next one's a little bit more interesting, right? We have a rational function. G of x has a denominator, so there's a chance that there could be a number out there that makes us divide by 0 and is a discontinuity. So let's focus first on the denominator. What makes 4x plus 20 0? Well, you could factor out a 4 times x would give us 4x, and 4 times what gives us 20? It would be 5. So what would make us divide by 0? Does anything make this denominator 0? Well, two things would only multiply to be 0 as long as at least one of them is 0, right? 2 times 8 is not 0 because neither of those factors are 0. So we want to figure out what would make 4 0. Well, 4 is always 4. Can't make that 0. But what would make x plus 5 0? You could subtract 5 from both sides and see that if x was negative 5, we would be dividing by 0, right? You could practice by plugging into the original function. 4 times negative 5 is negative 20, plus 20 is 0. That number is definitely going to make us divide by 0. So there's our discontinuity. So we are discontinuous at x equals negative 5. And to say whether it's a whole or a vertical asymptote, we'd have to figure out, does it cancel with the numerator or not? So I'm going to look at the numerator. I want to factor this, so I want to multiply to be a negative 10 and add up to be 3. So it's nice to multiply to be a negative 10. We need a positive times a negative for sure. And we need factors that differ by 3. And we're going to make the bigger factor the positive one so that they add up to be positive 3. So we're going to say 5 times negative 2 is negative 10, and 5 minus 2 gives us that 3. So what happens with our discontinuity? Does it cancel out and is a whole, or does it not cancel so it's a vertical asymptote? The x plus 5s do cancel. So the one that cancels factors and cancel the numerator, we must have a whole at that discontinuity. So I'm going to label it as a whole. And last thing I'm going to practice is this interval of continuity. I'm continuous everywhere except for at this whole, at x is negative 5. So my interval of continuity is going to be before negative 5 So I have before -5. How would I write that in interval notation? Well, that's from -infinity to -5. All of the negative numbers before -5. Union, we use a union when there's more than one interval. Any number after -5, right? So from -5 to infinity. So before -5 and after -5, I'm continuous. I'm continuous everywhere except for -5 is what this says. Those round parentheses mean everywhere except -5. Let's do that again. We have h of x. It has a denominator. We want to see what would make us divide by 0. So we need to factor that denominator. X squared minus 9 is a difference of two square numbers. What's getting squared is x and 3. So it's going to be x plus 3, x minus 3. So I have two numbers, possibly, that make me divide by 0. I want to see what would make x plus 3 0 and what would make x minus 3 0. Well, to make x plus 3 0, you could subtract 3 from both sides. If x is -3, we're discontinuous. You practice by plugging it into the original piece. -3 squared is 9. Minus 9 is 0. Just make sure if you use your calculator on that, you have to put that -3 in parentheses for it to work correctly. Then to make x minus 3 0, we'd have to add 3 to both sides. X would have to be positive 3. Again, plug it into the original to check that. 3 squared is 9, minus 9. It really does make that denominator 0, so we must have factored correctly. So we have two discontinuities. Discontinuous at x equals -3 and positive 3. And when I identify, do we have wholes, vertical asymptotes, or maybe one of each? So to identify the type of discontinuity, we factor the numerator. I'm going to plot a 5, my greatest common factor, times x. And then 5 times -3 will give me -15. So do any of these factors cancel? Yes, the x minus 3 cancels. So that x is positive 3 must be a whole. The one that doesn't cancel is a vertical asymptote. Notice in these numerators, we might have some numbers left over, like we had an x minus 2 and a 5. Numerators don't give us discontinuities. You're allowed to have 0 divided by anything. 0 divided by 10 is just 0. 0 divided by 80 is 0. So you can have 0 in the numerator. You can never have 0 in the denominator, though. So we are only looking at denominators for discontinuities. And then the only reason we factor the numerators is to see the type of discontinuity. So we have two discontinuities here at -3 and positive 3. -3 is a vertical asymptote, positive 3 is a whole. I like to write a number line because it helps me make this interval of continuity. Where is it continuous? Well, it's continuous before -3. So we would say -infinity to -3. Union, it is continuous between -3 and 3. -3 and 3. Union, it is also continuous after 3. So 3 to infinity. Not really nicely written on one line like it could be, but that's what I have for space. Before -3, between -3 and 3, and after 3. It's all continuous. So see if you can pause the video and try this last one. Factor the denominator first because discontinuities come from the denominator. See what makes you discontinuous. Then factor the numerator to see the type of discontinuity. If it cancels, it's a whole. If it does not cancel, it's a vertical asymptote. I'm going to get started here by multiplying to be a -28 in the bottom. So it must be a positive times a negative. It must differ by 3. So I'm going to have a bigger positive number to have a positive 3 when I add up. So I have positive 7 minus 4 gives me 3, and 7 times -4 is -28. So I have two discontinuities. What makes x plus 7 0 is -7, and what makes x minus 4 0 is positive 4. And you can set it up like an equation like these if that helps you, or you might be able to tell the discontinuity without having to set it up. X plus 7 is 0 when x is -7, and x minus 4 is 0 when x is positive 4. So we have two discontinuities. Here are my discontinuities. And to tell the type, I need to factor the numerator. The numerator I want to multiply to be a negative 20. So I have a positive times a negative. And I want factors that differ by 1 because there's really a 1 in front of this x. So factors of 20 that differ by 1 would be 5 and 4. Since I want to add up to be a positive 1, I must have the bigger number be the positive number. So 5 minus 4 is 1, and 5 times negative 4 is negative 20. Does anything cancel? Yep, the x minus 4 does. So that 4 is a whole. And then the x plus 7 stays, cannot cancel, so it's a vertical asymptote. I'm going to go right below here and figure out this interval of continuity. Where would it be continuous? So I like to write a number line. It's continuous before negative 7, between negative 7 and 4, and after 4. And seeing it helps me figure out how to write it in interval notation. So I would say it's continuous from negative infinity to negative 7, union between negative 7 and 4, and union after 4. So 4 out to the right means 4 all the way to positive infinity. So with continuity, you could be asked either way. You could ask me, where are you discontinuous? You would just say negative 7 is a vertical asymptote, 4 is a whole. Or sometimes you could be asked, where are you actually going to be continuous? Where we are going to be continuous is negative infinity to negative 7, union negative 7 to 4, and 4 to infinity. Everywhere from negative infinity to positive infinity except for at negative 7 and 4, in other words.